Hi friends, this is Dr. N.R. Patil. Today we will see how to draw velocity and acceleration for a given problem. Let's start. So this is the given problem. You can pause it and read it. Remember to know you have to find the velocity u and it is omega into r. Okay, and by using this formula you can find the velocity. Remember it is 283. Now the step number one is you have to draw space diagram. And to draw space diagram, you have to take some scale. And I have taken 1 centimeter is equals to 100 millimeter. So these are the various lengths and their length in millimeter. So you have to convert it into centimeter. And for that, this is given 150 millimeter divided by scale, that is 100. So you will get centimeter 1.5. Similarly, I have calculated different length of the various length in centimeters. So let's start. So before you draw any configuration diagram, check how many fixed points are there. In this configuration diagram, there are two fixed points O and P. This O and P is given here. And from this O, this P is located at 150 millimeter towards left and vertical distance is 420 millimeter. So let's draw. First of all, locate point O. So this is point O. Now, then locate the crank at 30 degree. It is given. So this is 30 degree. 30 degree from this to this one. Draw this. Now this is point A. Remember this. Now look at point P, which is 150 millimeter towards left of this O, and vertically it is 420 millimeter from this point. It is 420 millimeter. Draw one more line. This is point P. Once you look at these 2 points, let us draw AB, this AB and this PB. And for that you have to look at point B. So look at point B. So this is point B. You have drawn arc, two arcs like this. One is AB, 4.5 centimeter from this point A, and from P it is PB, 2.4 centimeter. So you got this point. Join the points. Now there is a point C, isn't it? So you know BC. So this is point B. C is a point C from B is 2.1 centimeter. Get it? So this is point C. Once you look at point C, now look at this slider. To look at this slider, you know this is the stroke is 30, stroke line is 300 millimeter towards right of this pivot point P. So from this point P, take 30 millimeter towards right and draw a vertical path. So this is a vertical path of a slider. Now get this point D. How to get this point D? CD given 660, that is 6.6 centimeter from this point C. Take compass, take radius 6.6 centimeter, and then get this arc. So this is point D. Once you get this point D, label all the points. So this is configuration diagram. I hope you understood. Now, step number 3 is to draw velocity diagram. So this is velocity diagram. You have to take some scale. I have taken 1 centimeter is 0.5 meter per second. And everyone know in the previous slide, velocity of A with respect to O calculated was 2.82, isn't it? 2.82 meter per second. Remember this. Now, when you take scale 1 centimeter is 0.5 meter per second. Now I want to draw a vector which represents this meter per second. So how to draw? Let us see. Friends, to draw the velocity diagram, you have to first locate two fixed points O and P here. So I have located point O and point P, which is fixed. Now you have to tell yourself that velocity of A with respect to O is perpendicular to this link VAO, and this link is rotating in clockwise direction, and that's why this arrow is towards in the direction of rotation. So you know magnitude VAO, you know direction, this direction. So with these two information you can draw first vector like this. So this is the first vector. So this is the direction of vector. It started from these fixed 2 points O and P and it ended here. So this is first point A. Okay. Now second point is B. So velocity of B with respect to A is always perpendicular to this link. So this is velocity of B with respect to A. So you know the direction, but we don't know magnitude, isn't it? So how to draw? Simply draw a line. Okay. But from where? Velocity of B with respect to A. Either you know B or you know A. In this case, we know A. From this point A, draw a line perpendicular to this AB. So draw this line. We will not get any point. But again, velocity of B with respect to P. Velocity of B with respect to P is like this and perpendicular. So this is velocity of B with respect to P. We don't know magnitude, but we know direction perpendicular to PB. Now P is fixed point here. You already marked. So from this point P, draw a line perpendicular to this PB. Draw. The intersecting point is B. So here you get B. Now how to look at this point C? For that you have to take ratio of distance. Ratio of distance, and that can be taken as capital PB by PC is equals to small pb by PC. So you know PB, you know PC, you know small pb also. So you don't know PC. And by this ratio you can find and locate this point C. Once you locate point C, now velocity of D with respect to C is again perpendicular to this link. So this is VDC. So I know direction perpendicular to the link CD, but I don't know magnitude. So what to do? Draw the line perpendicular to this line CD from this point C. Draw this line. Okay. Now the slider, this is slider D, slides up and down vertically. So draw a line passing through this point O and P vertically. The intersecting point here will be D. So this is C, isn't it? So this way you will complete the velocity diagram. Next step is to prepare this table for acceleration diagram. In this table, you have to remember this is link name, this is link length in meters, then velocity. From velocity diagram you have to find this, excuse me. Then there are two components of acceleration. One is centripetal component Fc, second one is Ft. And you know the formula, v square by link length and alpha into link length. Friends, as you know velocity and its length, so when you know velocity and length, you can find Fc, that is centripetal component. So what you have to do, you have to take square of this value of velocity divided by this length, that is 0.15. It will give you this 53.3. Similarly, you can get these values, that is centripetal component of acceleration. There is no tangential component of acceleration because the crank is rotating at constant speed, so you will not find any Ft here, isn't it? But we know direction. Direction is known. So how to draw acceleration diagram? Let's see. And for that, you have this space diagram, and to draw acceleration diagram, you have to take scale. I will take scale. 1 centimeter is equals to 15 meter per second square. Okay. Now we have acceleration of A with respect to O. And what is the component of acceleration? We know Fc. We know magnitude and we also know direction. This arrow indicates direction and FC is magnitude in the previous slide you have seen. With these two information you can directly draw a acceleration vector. So let us start. First of all, locate two fixed points O and P and then draw a line in the direction. This arrow you have to remember. From this point O and P you have to draw a line in this direction. Okay, so I have drawn it. So you will get this point as a A. You may say A dash as its acceleration. Now, after A there is the next point B. So you have to say acceleration of B with respect to A will have two component Fc and tangential component Ft, isn't it? So Fc which acts towards A and Ft is perpendicular to AB. So let us draw. Do you know Fc magnitude? Yes, I know Fc magnitude of AB. Do you know direction? Yes, I know direction. Moving to downwards, isn't it? So this is direction, this is magnitude. You can draw the vector. So this is the vector I have drawn. Next, tangential component. I don't know magnitude. But I know it is perpendicular to link AB. So I have drawn this line perpendicular to this AB in configuration diagram. Next, acceleration of B with respect to P will have two components. This is towards P, Fc, and perpendicular to this link Ft, isn't it? So you know Fc, magnitude, you also know direction. So draw these two from fixed point P. So this is point P. Two lines will intersect somewhere here. So this is the required point B. Okay, so we got B. Now I want to find C. Again, follow the distance ratio formula and get point C. So before that you join A dash, B dash and also join P and B dash. To get this point C, take ratio, distance ratio and you will get point C here. Okay, this is point C. Once you get point C, now what is the remaining? D, slider. So what you have to say, acceleration of D with respect to C will have two components. One is Fc acting towards C and perpendicular Ft. So you know magnitude Fc, you know direction. So draw from point C. Draw. Next, Ft, you don't know magnitude but direction is known. Draw perpendicular. Once you draw this, friends, last one, the slider is moving in vertically up and down, isn't it? So draw vertical line passing through this fixed point P and O to get the final point, that is D dash. Once you get all these points, join and finally level, isn't it? So this way you have to draw acceleration diagram. Now what you want to find? You have to find acceleration of slider, and that is Fd is equals to, you know vector, this is D dash, this is O. Measure the length in this acceleration diagram. So length of vector OD dash into scale. So your scale is 15 and this way you will get meter per second. Friends, this is the way to find the acceleration. I hope you understood this. Thank you very much.